Hi guys, I thought today we'd go through the process by which we can rationalize denominators in fractions. So what we've got here is we've got a couple of numbers or a couple of fractions with irrational denominators. So a irrational number is a number that cannot be expressed in the form a over b. So it cannot be expressed as a integer over another integer. Now common irrational numbers are things like pi, e, and the square roots of particular numbers. Square root of 2 is 1. So these ones cannot be expressed in the form a over b. So the way that we go about rationalizing the denominators, so getting the square root out of the denominator, is we multiply each of these fractions by a particular version of 1. Now, we know that 1 can be expressed as a fraction as well, where the denominator and the numerator are equal. So a over a is going to be equal to 1. X over x, 4 over 4. These are all equal to 1. So what we can do is we can move the denominator, like in the first one, this is the simple one, we can move the denominator or the square root in the denominator up to the top by multiplying this fraction by 1, or the square root of 2 over the square root of 2. Now, what this has the effect of doing is we have in the denominator square root 2 times the square root of 2 is, would you believe, just 2. And 1 times the square root of 2 is the square root of 2. So you can see now that I have a rational number in the denominator. So I've completed my task of rationalizing this denominator because I've gone from an irrational number, square root 2, to a rational number, 2. Now, most exams or most maths classes or maths teachers will sort of prefer or ask you to leave all of your answers, especially when you're doing trigonometry, in a rational form. So you need to have a rational denominator. So if we're going to go on to the second one, we'll change color, but the same method applies. What we've got in the denominator is we have a rational number and an irrational number. So what we're going to do is we're just going to work with the irrational number first. So we're going to multiply this fraction by another version of 1. In this case, it's going to be the square root of 5 over the square root of 5. Now, what we have is we're going to then end up with root 5 times root 5 is 5. So we're going to have in the base 2 times 5. And in the numerator, we're going to have 7 times root 5, or 7 square root 5. Now we can simplify that all by doing the multiplication in the denominator, and we're going to have 10 in the base and 7 square root 5 in the numerator. So you can see again, with using this tool by multiplying the fraction by 1, or by a fraction which is the numerator and the denominator are the same, we're able to get the irrational part of the denominator into the numerator. Okay, now this last one, how do we do this one? Now, this one is slightly different from the other two. We're going to take advantage of a binomial expansion method called the difference of perfect squares. Now, what the difference of perfect squares are, if we have a number plus another number, and then we times that by the same number minus that number, we end up with a squared minus b squared. Now we're going to use this in the case of a denominator which has a addition or a subtraction sign in it, because we can't just multiply it by a single irrational denominator. We have to multiply it by a set of numbers that will take account for the negative sign in the middle. So what we can do here is we're going to multiply both of these by a version of the difference of perfect squares. So I'm going to still multiply this fraction by 1 because I don't want to change the value of the fraction. But the value of 1 that I'm going to write is it's going to be the square root of 3. Here it is minus 8. I'm going to put on this fraction the square root of 3 plus 8. And on the top, I'm going to do the same thing. Now, in our binomial expansion, if we have one number plus a number and a number minus a number multiplying together, like we have in the denominators here, it's going to equal the first number squared. So in this case, it's going to be equal to, let's just draw the line, the first number squared, so square root of 3 squared is just 3, minus the second number squared. So minus the second number squared. So the second number here is 8. 8 squared is 64. And in the numerator, we're going to have 15 times the, we're going to use the distributive law here. So we're going to treat the numerator like this. We're going to say we've got 15 bracket square root 3 plus 8. So we're going to go 15 square root 3 plus 15 times 8, which is 120. So we can simplify this. In the base, we have negative 61. And in the numerator, we have the same 15 square root 3 plus 120, which should be written, the negative sign from the denominator can come out the front of the fraction, and that's going to be 15 square root 3 plus 120. So you can see that when we add a addition or subtraction sign into the denominator, which we need to rationalize, it makes the process a little bit more complicated. However, if we use the difference of perfect squares method, it's quite easy to come out with the solution that's correct. And I guess the only way that you can get really good at these is by practice, and but essentially they're all going to involve something like this. So I hope that helped, and I'll see you again next time.